Hello friends, good morning and welcome to our new session, next session of Stiffness Matrix Method. If you are seeing this video first time, I request you to look at my first 3 videos on this chapter, Stiffness Matrix Method, because today's video will be a little bit complicated problem that we are going to deal with. So I again request you to please see my first 3 videos. First video is introductory part of Stiffness Matrix Method. Second video is on a simple portal frame, analysis of this frame using Stiffness Matrix Method, which involves 2 unknowns. Second problem is having 3 unknowns, and today is also having one more frame with 3 unknowns, but it is more complicated than previous 2 questions. So let us start with the frame. So we have this portal frame, which is a sway type of portal frame, which is clearly indicating the sway, and there are 3-4 criteria for a frame to be a sway type of frame. One thing is height of columns is different. Second thing, there is unbalanced horizontal force on the frame. So these 2 are the factors which will contribute for frame to be a sway type of portal frame. So let us start analyzing this. So our first step will be finding out kinematic indeterminacy of the frame. So this is a frame with 3 unknowns. So Ki is equal to 3, kinematic indeterminacy. So which are those 3 unknowns? Those 3 unknowns are delta, which is sway of the frame, theta b, rotation of joint B, and theta c, rotation of joint C. So we shall give numbering to these unknowns. Delta 1 as small delta, sway of the frame, delta 2, rotation of B, and delta 3 as rotation of C. So giving numbering to these unknown displacements is important, and depending on these numberings, the stiffness matrix will be formed. So now second step is fixed end moments. Okay, fixed end moments. So fixed end moments will be, if you see 2 columns, they do not carry any external load. 50 kN is on the junction of column and beam, so it will not be considered in column. Okay, so MFAB, MFBA, MFCD, and MFDC, these 4 values will be 0. There will be only 2 values of fixed end moments. One is MFBC, which is minus WL square by 12, so minus 30 into 4 square upon 12. So how much is the value? Let us see. So 30 into 4 square upon 12. So it is minus 40. Minus 40 kilonewton meter. And MFCB, it is plus 30 into 4 square by 12, so it is plus 40 kilonewton meter. Okay. Now next step will be summation of fixed end moments, but carefully see which is our first unknown, linear displacement. So instead of summation of fixed end moments, we will have to first carry out summation of horizontal reactions, where on B and C we are saying delta, it is occurring at 2 places. One is at this location, another is at this location. Both delta values will be same. So both though there are 2 delta values, they will be treated as only one unknown because both are equal. So we will have to find reactions at these 2 locations, HB and HC, horizontal reactions, and that will be your PL1 value. Please remember. This is what is different from previous two questions. So sum of horizontal reactions at B and C due to external loading. Due to external loading. So it is HB plus HC. So we will have to find HB and HC. But we do not have any external loading on columns. So if there is any external loading, how will you proceed? Even though it is 0, I am going to explain it here. Draw free body diagram for column AB. Show fixed end moments here, which are 0 in this case. And find out HB. You take summation of moment about end A, it is equal to 0. So HB will be 0 here. Similarly, take free body diagram for column CD. Show fixed end moments here, which is again 0 fixed end moments. Take summation of moment about D. So HC will be 0. So HB plus HC is 0. Okay. So our PL1 is HB plus HC 0. Okay. Then PL2. What will be PL2? Now our second unknown is rotation. So we will have to take summation of fixed end moments. So summation of fixed end moments at 2 due to external loading. Okay. So it is joint B because it is rotation of joint B. So on B we have two fixed end moments. One is MFBA, which is 0, another is MFBC, which is minus 40. So MFBA plus MFBC. So it is 0 minus 40. Let us check again. 0 minus 40. Okay, so it is minus 40 kilonewton meter. Okay. What about PL3? PL3 is again summation of fixed end moments on joint C due to external loading. So MF, CB and CD plus MF, CD. Substitute both the values. MF, CB, C, how much is this? Plus 40 and CD 0. So it is 40 plus 40 kilonewton meter. So three values are there of the matrix or the equation. Then P1. What is P1? P1 is corresponding to first unknown. First unknown is linear displacement. Linear displacement is caused by linear force. So on first unknown location, that is on joint B, do we have any external horizontal force? Yes, 50 kilonewton. So P1 will be 50. Okay, P1 is 50 kilonewton. P2, P3, they are corresponding to theta B and theta C. So we will have to look for external couples which are absent on both the locations. There is no external couple on B and C. So P2, P3 is 0. Okay, so these are our 6 values of the matrix element or the equation. Now we will go for K values one by one. So just for the reference, I will note down again PL1, PL2, PL3 and P1, P2, P3. So PL1 0, correct? PL2 minus 40, PL3 plus 40, P1 50, P2, P3, 0. So these are 6 values. Okay. Now we will go for these unknowns one by one. So now we will apply our first unknown as unit value, which is linear displacement on joint B. So we are allowing the frame to undergo sway. Okay. So step number 3 or 4, whatever is the number, apply unit horizontal displacement at 1. Okay. So this will be your first unknown, which we are making 1. Other unknowns we are making 0. We are removing external loading. So if you apply horizontal displacement here, both the columns are going to undergo sway. Okay. So this value is 1. Delta is 1. Now because of this one unit displacement, there will be moments induced. So these are nothing but moment due to sway, 6 EI upon L1 square. Okay. Please remember, moments because of sway will be same on both the ends. It will not be half value on fixed ends. So 6 EI upon L1 square. So where are our locations? Our first location and second location is at same place. This is 1. 2 is also here and 3 is here. Okay. So what will be your K11? It will be algebraic sum of horizontal reactions at B and C due to unit displacement of 1. Okay. So these are HB and HC. So we will have to find HB and HC because of sway. So because of sway, there are moments induced in the columns. So go for finding out horizontal reactions on B and C. Why? Because delta is on both the locations. Okay. So take free body diagram of column AB first. Show there moments due to sway 6 EI, delta is 1 upon L1 square. This is height L1. Here is also same 6 EI upon L1 square, and find out HB. So I will assume the direction of HB towards right. I will change this. I am assuming towards right. So here I am going to take now summation of moment about A. Okay. So HB into L1 minus 6EI upon L1 square. This is also minus 6EI upon L1 square, so I'll make it 2 times. So this is minus 12EI upon L1 square. So HB is 12EI upon L1 cube. So this horizontal reaction in the calculations comes to be positive. It means my assumed direction towards right is correct. Similarly, I will find HC. So here again I will show these two moments, 6EI by L2 square. Here is 6EI by L2 square, and this is again HC. This is height. So if I take summation of moment about D, I will again get HC, same 12EI upon L2 cube. L2 stands for height of column CD. Okay. So this will be my K11. So K11 is 12EI upon L1 cube this is for column AB plus 12EI upon L2 cube. This is for column CD. So 12EI upon 4 cube plus 12EI upon 2 cube. Okay. So let us see how much is this K11. So it is 1.6875, so I'll make it 1.69 EI. So this is your K11. It means algebraic sum of horizontal reactions at 1 due to horizontal unit displacement of 1. Now see your second location here. Second location is corresponding to rotation. So we will have to see how much is moment. So what is second value? K21 is moment at 2 due to horizontal displacement of 1. How much is that? Minus 6EI upon L1 square. Why minus? Because it is anti-clockwise. Okay, it is anti-clockwise. So minus 6EI upon 4 square. So how much is this? 6 by 4 square. So minus 0.375 EI. It is K21. Now K31. K31 is moment at 3 due to horizontal displacement of 1. How much is that? Again go for location 3. 3 is rotation, so corresponding to rotation we will have to go for movement. So minus 6EI upon L2 square. L2 is height of CD. So minus 6EI upon 2 square. So minus 6 by 4. It has to be 1.5. So minus 1.5 EI. Okay. So we have got 3 elements of the stiffness matrix. Next, we will take our second unknown. We will make it 1 and Again we will find 3 more elements. So let us do it. So step number 4, apply unit rotation at 2. So if you rotate joint B, what will be the deformed shape? Let us draw. It is going to be here, clockwise rotation. Okay. So this is 1 radian rotation. So what will be values? Let us see one by one. Because of this rotation, here the stiffness will be 4EI upon L1. So its half value will be here. It is of no use for us. Second stiffness is here, 4EI by L3 we shall say, because L2 we are saying for column. And its half value will come here. So 2EI upon L3. So this is our second location. Our first location is 1 and 2 are on same point, and 3 is here. Okay. Now when we have applied some action on 2, what are the reactions induced on 1, 2 and 3? We have to find. So K 1, 2. K12. What is K12? K12 is horizontal reaction on 1, due to unit rotation of 2. Okay. Why reaction and why not moment? Because our first unknown is linear displacement. Linear displacement is caused by horizontal force or reaction. Okay, force or reaction. So we will take free body diagram of column AB. So here I will show the half value of 4EI by L1. So it will be required. Okay. So draw column AB, free body diagram, and find out horizontal reaction on B. So this is 4EI by L1, this is 2EI by L1. Both are clockwise, so it has to be towards left. So this is HB. So take summation of moment about A. So this is end B, this is end A. So minus HB into L1, height is L1, plus 4EI by L1 plus 2EI by L1, it is equal to 0. So HB will be 4 plus 2, 6. Bring it on right hand side, it will become minus 6EI upon L1 divided by minus L1. So it is minus 6EI by L2 square. Minus actually gets cancelled, but still I am saying it minus. Why? Because direction of reaction is towards left. Hence I am keeping this minus. Please remember. So HB is minus 6EI upon L1 square. So this is K12. What is K12? Minus 6EI upon L1 square. So what is L1? 4. So minus 6EI upon 4 square. It has to be equal to K21. So minus 0.375 EI. Okay. Now I will need this part, so I will rub this. I will keep K values here. It is 1.69 EI first value. Then K21 minus 0.375 EI and K31 minus 1.5 EI. Okay. So we need now two more values. We have got on location 1. Now K22. What is K22? Movement at 2. Why movement? Because second unknown is rotation. So movement at 2 due to unit rotation of 2. Okay. So how much is value here? There are two values, please remember. One is 4EI by L1, another is 4EI by L3. So let us note them here. 4EI by L1, which is of span AB, plus 4EI by L3, which is for span BC. So L1 height is 4, so 4EI by 4, plus 4EI by again 4, because span BC is also 4, so K22 is 2EI. Next, K32. What is K32? Moment at 3 due to unit rotation of 2. So it is 2EI by L3. L3 means span BC. So substitute 2EI by 4. So it is 0.5 EI. Okay. 0.5 EI. So three more elements we have got. K12, K22, K32. Now we will apply unit rotation at 3. Okay. So let us draw the diagram first. And now apply unit rotation on 3. So 3 is on joint C here. So draw the deformed shape first. Clockwise rotation. It will be something like this. Yeah. So this is 1 radian rotation. This is 1 radian rotation. So here is 4 EI upon L2. For this 4 EI upon L3, here 2 EI upon L3. Okay. So our first location is either here or here. You can take anything. So in this case we will take here, because delta on joint C as well as on B is same. Okay, this is then 3 and then here 2. So K13. What is K13? Horizontal reaction on 1 due to unit rotation of 3. unit rotation of 3. So we will get this value from here, column CD. So draw free body diagram for column CD. Show there the moment values. 4 EI by L2 is here. Its half value is on D, 2 EI by L2. And then show reaction. So C, take summation of movement at D. So minus HC into L2, this is height L2, plus 4EI by L2 plus 2EI by L2. So I will directly write plus 6EI by L2. It is equal to 0. So HC is minus 6EI upon L2 square. Again I am keeping this minus sign because HC is towards left. Okay, HC is towards left. So this is K13. Is it matching with K31? Let us see. So minus 6 upon 4 is minus 1.5, yes. So minus 1.5 EI. Okay. So I again need some space. So what I will do, I will rub this. So this is 2 EI, K22 is 2 EI, K32 it is 0.5 EI, and K12 is minus 0.375 EI. Okay. Now remaining two values we will get. K13 we have got, I'll list them here. K13 minus 1.5 EI. Now from this step we have to get two more values. One is on 2, another is on 3. So K23. What will be K23? Moment at 2 due to unit rotation of 2, and value is 2 EI by L3. 2 EI upon L3. This is for span BC. So 2 EI by 4, which is 0.5 EI. Is it matching with K32? K32, where is it? It is here, yes. Matching. Last is unique value K33. Moment at 3 due to unit rotation of 3. Okay. So location 3 is here, and there are two values on 3. One is from beam, another is from column. So 4 EI by L3, 4 EI upon L3, which is for span BC, and 4 EI by L2, which is for span CD. Substitute one by one. So 4 EI by 4 plus 4 EI by 2. 4 EI by 4 is 1, 4 EI by 2 is 0.5. So 1.5 EI total. 1.5 EI. So 9 values of the stiffness matrix we have got. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 matrix values, 3 PL values, 3 P values. All we have got. Now we will substitute this in the matrix equation, and then we will solve 3 by 3 matrix. So our 3 unknowns: delta 1, delta 2, delta 3. These are 3 unknowns. Then K inverse. So K11 1.69 EI then minus 0.375 EI, then minus 1.5 EI, K22 2 EI, K23 or 32.5 EI, and K33 1.5 EI. So inverse of this matrix multiplied by P values P1, P2, P3. So P1 is 50, P2, P3 both are 0. PL values now. So PL1 is 0, PL2 minus 40, PL3 plus 40. So let us solve inverse of this matrix and then solve the problem, get the answer. So this is the inverse of the matrix. I am not going to explain this in details because how to solve a 3 by 3 inverse matrix I have already shown it in our previous session. So 1 upon 5.34 EI, this is the determinant value of the 3 by 3 matrix, and these are cofactors. And then this second bracket, 50 minus 0 is 50, 0 minus minus plus 40, 0 minus 40 is minus 40. Now we will get the unknowns one by one. So delta 1 is multiplication of matrices divided by determinant value. So 5.75 into 50 plus 0.375 into 40 plus 2.81 into minus 40. This is totally divided by 5.34 EI. This is how you get delta 1. Let us calculate. So answer is 35.6 upon EI. Okay, 35.6 upon EI. Let us now calculate delta 2. Now I will calculate directly. 0.375 into 50 plus 2.81 into 40 minus 0.28 into minus 40 upon 5.34 EI. So it is 26.66 upon EI. And delta 3, 2.81 into 50 minus 0.28 into 40 plus 3.23 into minus 40 divided by 5.34. So it is 0.018, or we should say 0.019 upon EI. Yes, so the major task is over. Now we will go for final movements. So these are our final movements. MAB minus 0.02, MBA 13.31, MBC minus 13.33, MCB 53.35, MCD minus 53.36, and MDC minus 53.38. These values we have got using slope deflection equations. Please remember. So those who don't know how to use slope deflection equations, please refer my first session on slope deflection method. And this is the final BMD on tension side for this particular frame. I have not gone into details for drawing how to draw this bending moment diagram on tension side. Those who do not know how to draw it, please refer my earlier videos on slope deflection method. There you will get a clear idea about how to draw these bending moment diagrams. If you have any difficulties, please let me know. If you are watching this first time, please refer my earlier videos on stiffness matrix method, because if you see this video very first time, you will not understand this. Thank you very much.